Welcome back to my YouTube channel. I am Honey. So today we'll be discussing what is number system. So the topics I'm going to cover in number system are numerals, face value and place value, types of numbers, divisibility rules, basic number theory. So first, what is a number system? A system in which we study different types of numbers, their relationship and rules governing them is called number system. So in Hindu Arabic system, we use the symbols 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these symbols are called digits. So out of these 10 digits, 0 is called insignificant digit, whereas others are called significant because 0 has no value and others has some value. And what is numerals? A mathematical symbol representing a number in a systematic manner is called numeral, so which is represented by a set of digits. So you can see one example here. So we'll write from right to left. Ones or units, tens, hundreds, thousands, 10,000, lakh, 10 lakh, crore, 10 crore. So you can see in this example when we write this example is like 30 crore 87 lakh 61,436. And similarly the second example is, so you can see here ones, tens, 100,000, 10,000, lakh, 10 lakh, crore. So it is 6 crores 20 lakhs 15,900. Now let's see what is face value and place value of a digit in a number. So generally by seeing the name face value we can understand its own value, nothing but digit itself. So if you take this example, so the face value of any digit in this particular numeral is itself. So the face value of 8 is 8, the face value of 7 is 7, and so on. And when you take the place value or local value, it is nothing but place value means it is with respect to its position or place. So here you can see this example. So ones, tens, hundreds, thousand, 10,000, lakh, 10 lakh. So if you take the place value of 8, it is there in 10 lakhs position. So you have to multiply 8 with 10 lakhs. So you have to multiply 8 with 10 lakhs. So you will be getting 80 lakhs. And similarly place value of 4 is, here it is 4 multiplied by 1000 as it is in thousands position, so you call it as 4000. And similarly place value of 2, it is there in tens position, so you have to multiply it with 10, so you will get 20. So this is what face value and place value. So you will be getting some questions regarding to this topic. And next let's see what are the types of numbers. So we have vast varieties of numbers, so let's discuss one after the other. Okay, so natural numbers. So generally whatever the counting numbers we use are called natural numbers, which are denoted by n. Nothing but n is equals to 1, 2, 3. So all natural numbers are positive. Okay, 0 is not a natural number, and as 0 is not a natural number, the least or smallest natural number is 1. And next comes the whole number. Whole number is nothing but all the natural numbers including 0 is called whole numbers. So it is denoted by W, and W is equals to 0, 1, 2, 3, like that. Combination of 0 as well as natural numbers is whole number. Okay. So here as 0 included, it is the smallest whole number, and whole numbers don't have negative, so these are called non-negative integers. Okay, so let's see what is integers. So whole numbers and negative numbers form the set of integers which is denoted by I. So you can see here negative numbers, 0, and positive numbers. So there are two types of numbers you can see. So positive numbers, natural numbers are called positive numbers, which we have already seen. It is denoted by I plus, which is equals to 1, 2, 3, like that. And negative numbers are called, so negative of natural numbers. So for natural numbers which are 1, 2, 3, now for that if you put minus, those are called as negative integers. So that is represented by I minus. I minus is equals to minus 2, minus 1, minus 2, like that. And what about 0? 0 does not come under positive or negative. It is neither negative nor positive. So this is called as neither negative or positive integer. So even numbers are nothing but which are divisible by 2. are called even numbers. Like in the units place, it should have 0, 2, 4, 6, 8. And odd numbers are which are not divisible by 2 are called odd numbers. So in ones place, generally you will have 1, 3, 5, 7 or 9. Now the most important thing is prime numbers. So some questions you will be getting from the prime numbers as well. So any counting number is called prime number when it is exactly divisible by 1 and itself. So it should have only two factors, that is 1 and itself. Okay. So for example 2, 3, 5, 7, 11, 13. So now let's see what exactly the prime numbers are in detail. Okay. So there are 15 prime numbers between 1 and 50 and 10 prime numbers between 50 and 100. So totally from 1 to 100 we have 25 prime numbers. Okay. And 2 is the only even number which is prime. So other numbers which are divisible by 2 are not primes. Only 2 is the even prime. Okay. And a prime number is always greater than 1, and 1 is not a prime number. So we have seen 1 is uh, not a prime number, and the lowest odd prime number is 3. Okay. So every prime number which is greater than 3. So far we have seen 1 is not a prime number because prime number starts with greater than 3, and 2 is a least even prime number and the only prime number, only even prime number, and 3 is the lowest odd prime number. And after 3, so if you want to represent any prime number, so it will be in a form of 6n plus 1 or 6n plus 5. So 6n plus 5 can be represented as 6n minus 1 also. What is this n? So n is an integer. Okay. So now let's see what exactly this is and how does it work with an example. Okay. And before that, I will tell you test for a number to be prime. So they'll be asking you questions like they'll give a number and ask you whether it is a prime or not. Okay, so how to do that? Suppose let us assume the given number is p. Okay, and n be the smallest counting number. So n square is greater than or equal to p. This condition has to satisfy. So now what you have to test is p is divisible by any of the prime numbers which are less than or equal to n. Suppose if it is divisible, then it is not a prime. If it is not divisible, then it is a prime. Okay. Now let's see these two things in with an example. So now let's see any prime number which is greater than 3 is represented by 6n plus 1 or 6n plus 5 or 6n minus 1, where n is an integer. So how that is possible, let's see. So let's take n is equals to 1. Okay, so 6 ones are 6 plus 1, which is equals to 7. So 7 is a prime number. And when you take n is equals to 2, you get 6 2s are plus 1. So which is 6 2s are 12 plus 1, 13. 13 is also prime number. Now let's see n is equals to 1 in this particular 6n plus 5. So 6 ones are 6 plus 5. So 6 ones are 6 plus 5 is how much? 11. 11. Second. 11 is also a prime number. If you take n is equals to 2, 6 into 2 plus 5. So 6 2s are 12 plus 5 is nothing but a 6 2s are 12 plus 5 is nothing but a 17, which is also a prime number. Now let's see n is equals to 1 in this particular 6n minus 1. So 6 ones are 6 minus 1, which is 5, which is a prime number. If you take n is equals to 2, it is nothing but 6 2s are 12 minus 1, which is 11. It is also prime. So that's why any prime number which is greater than 3 is represented by either 6n plus 1 or 6n plus 5 or 6n minus 1. Test for a number to be a prime. So what condition it has to satisfy? N square greater than or equals to p. Okay. So let's take an example 131. Whether it is a prime or not, now let's check. So this is our p value. Now how to take the n value? So n is any number whose square should be greater than or equal to p. If I take n as 11, 11 square, which is 121, is not greater than or equal to 131. If you take n as 12, 12 square, which is 144, is greater than or equal to 13. So you have to check prime numbers which are less than or equals to 12. Okay. So what are the prime numbers are there? 2, 3, 5, 7, 11. Next is 13, which is greater than 12, so this you cannot consider. So you have to check in whether these prime numbers are dividing this 131 or not. So as units place is 1, it is not divisible by 2. And so in next I'll be teaching divisibility rules in detail. So as of now we will divide with a general division. Okay, 3 fours are 12 and 11, 3 threes are 9, so this is also not divisible. And generally 5 to divide it with 5, units place should be of 0 or 5, so it is also not dividing. So now let's check it with 7 and 11 as well. So it is 131, 7 ones are 7, so it is 61, 7 sevens are 49, 7 eights are 56, so you'll get here 5, so it is also not dividing. Now let's see with 11, 11 131, 11 elevens are 121, so you are getting 10, so it is also not dividing. So by this we can say this 131 is a prime number. So next comes a composite numbers. So composite numbers are non-prime natural numbers. So nothing but it will have at least one factor which is other than 1 and itself. So like whichever are not prime numbers are called composite numbers. So they can be both even as well as odd also. So 1 is nothing but it's a neither prime number nor a composite number. So you cannot consider 1. Now let's see divisibility by 7. So a number is divisible by 7. So when the difference between twice the digit at one's place and the number formed by other digits is either 0 or multiple of 7. So let's see this with an example. So example is 658, which is 658. So this is divisible by 7. How? Let's see. So twice the units place, which is 8, 2 8s are 16. So and difference between other numbers and twice the units place, so 65 is the other number, minus 2 8s are 16, 65 minus 16 is 49, as 49 is divisible by 9, the whole number is divisible by 9. Or you can, so now let's see divisibility by 8. So like divisibility by 4, we'll be checking last 2 digits. Here we'll be checking last 3 digits. So if last 3 digits are divisible by 8, or if the last 3 digits are zeros, then you can say that the whole number is divisible by 8. So you can see here 2256, where 256 is divisible by 8, so whole number is divisible by 8. So here last 3 digits are 0, so the whole number is divisible by 8. As we already discussed divisibility by 9, sum of the digits is divisible by 9 and the whole number is divisible by 9. So here you have two examples you can check out. And divisibility by 10 is very simple. If the last digit is 0, then the whole number is divisible by 0. Next comes the divisibility by, so next is divisibility by 11. So sum of the digits at odd places and even places, if they are equal or the difference is divisible by 11, then the whole number is divisible by 11. So what is this odd places and even places? If you take this example, so 3, 4, 6, 2 are odd places and 2, 5, 8 are even places. If you add them, you are getting 15 and 15. So which are equal. So the whole number is divisible by 11. And if you take the second example, so here odd places 2, 7, 8 whose sum is 17 and even places 1, 3, 2 whose sum is 6. And the difference between these two is 11. So 11 is divisible by 11, so whole number is divisible by 11. So this is what divisibility by 11. And next comes divisibility by 12. So if a number is divided by both 4 and 3, then it is divisible by 12. So it has to be divisible by both 4 and 3. So we have seen how to check divisibility of 4 and 3. And for 14 it should be divisible by 2 and 7. And for 15 it should be 5 and 3. And for 16 we have to check last 4 digits. Okay. And for 18 it is even, nothing but it should be divisible by 2 as well as divisible by 9. Why these numbers? So you can see 4 3s are 12, 2 7s are 14, 5 3s are 15, like that. And for 18 it is 2 and 9, 9 2s are 18. And next comes divisibility by 25. If the last two digits are divisible by 25 or either zeros, then it is divisible by 25. And divisibility by 125 last. So divisibility by 125. So last three digits are divisible by 125 or they can be zeros. So in this example you can see last three digits are 125. So as 125 is divisible by 125, so this number is divisible by 125. So you will be asking questions like this. Okay, show that this particular number is divisible by 24. So to check whether a number is divisible by 24, what we have to say, take like 3 8s are 24. So for checking divisibility with 3, so what you have to take, sum of the digits, which is 36. So 36 is divisible by 3, so total number is divisible by 3. And for checking with 8, you have to check last 3 digits. So this 744 is divisible by 8, so whole number is divisible by 8. As this number is divisible by both 3 and 8, so this whole number is divisible by 24. So let's see some basic number theory. Okay, so the sum of first n natural numbers is n multiplied by n plus 1 by 2. Suppose if you are taking 10 natural numbers, 10 multiplied by 10 plus 1 by 2. And sum of first n odd numbers is n square. Sum of first n even numbers is n into n plus 1. Suppose if you are taking sum of squares of first n natural numbers, then that is n into n plus 1 into 2n plus 1 by 6. And next, sum of cubes of first n natural numbers is n into n plus 1 by 2 whole square. Nothing but n square into n plus 1 whole square by 4. Okay. And one thing I would like to tell you, the square of a natural number will never end in 2 or 7. So that is a hard code rule. And next comes the progressions. So arithmetic progressions represented by AP. Okay. So if a series of numbers are said to be in arithmetic progression, they have to be like A plus D, A plus 2D, A plus 3D, like that. So where the first term is A and a common difference between two adjacent numbers or adjacent things is D should be there. Okay, if you consider nth number as Tn and last number as L, so the nth term is equals to A plus n minus 1 into D. So this is the nth number. Suppose if you are taking 10th, this is a 10 and the starting number and difference between the two successive numbers. Okay, and sum of the numbers is n by 2 times 2a plus n minus 1 into D, or it can be n by 2 times a plus L. So this L is the last term. Okay. So you can see here example, how many natural numbers between 17 and 80 are divisible by 6. So here they are asking both. Okay, you can use arithmetic progression to solve this. So here by seeing this, you can see divisible by 7 means, divisible by 6 means, so after 17 you will be getting 18. Okay, 18 is divisible by 6. Next comes to 24, like that. In between 17 and 80 now. So in before 80, 78 is divisible by 6. So these are said to be in arithmetic progression because you have a starting term and you have a common difference. Okay, so where A is 18 and common difference is 6 and last term is 78. So with this you can find the n value. So last term 78 is equals to A plus n minus 1 into D. If you substitute, you will get n value as 11. So how many natural numbers are there in between 17 and 80 which are divisible by 6 means 11 natural numbers are there. So if you have a difference, common difference, then it is a arithmetic progression. Suppose if you have a common ratio, then they are called as geometric progression. Okay, AR square, AR cube. So these are said to be in geometric progression if the first term is A and the common ratio, that means ratio between these two terms is R, ratio between these two terms is R. Nothing but consecutive. So nth term is A times R power n minus 1 and sum of n terms. If you want to find sum of n terms, A times 1 minus R power n divided by 1 minus R. If this R value is less than 1, how to find the R value? Nothing but these two difference. These two ratio, right? And A times R power n minus 1 divided by R minus 1 is a sum if R is greater than 1. Okay, let's see one example. So find the sum of this, which is 2 square, like that, 2 power 10. Okay, so these are said to be in geometric progression, which is GP. So in which A is equals to 2, R is equals to, I told you now, ratio of these two. So 2 square by 2, which is 2. Okay, as r value which is 2 is greater than 1, so you will be taking a formula this one. Okay, so a times r power n minus 1 divided by r minus 1. So 2 multiplied by 2 power 10 which is n value, minus 1 divided by 2 minus 1 which is 2 times 1023 which is 2046. So this is how, by using AP and GB, we will be finding out sum or number of terms in series. Okay, now let's see basic algebraic formula. These all from childhood we are seeing. A plus b whole square is equals to a square plus 2ab plus b square. A minus b whole square is equals to a square minus 2ab plus b square. A square minus b square is equals to a plus b, a minus b. And there are some more you can check out. And this is an important one. Generally every time we'll be getting question from this particular two formulas. Okay, a cube plus b cube plus c cube minus 3ab is equals to a plus b plus c into a square plus b square minus ab minus bc minus ca. If a plus b plus c equal to 0, then you will get a cube plus b cube plus c cube is equals to this one. So if this multiplied by 0, you are getting cancelling this comes this side. So that's what these two are interlinked. Generally you will get a question from this. Okay, and there are some more. And Bodemas rule, which is very important. So to solve any kind of equation we must follow this Bodemas rule, or else you are getting a false answers. So you have to come in this order. Okay, first you have to remove the brackets, you have to solve whichever are there inside of brackets, and then do division, then do multiplication, then solve for addition, then solve for subtraction. And dividend rule, this is very important. Dividend is equals to divisor into quotient plus remainder. So I'll be explaining some examples on this. Okay, and distributive law. Generally distributive law everybody knows, but they will be asking, they'll be giving options and asking you what is distributive law. So then you should be able to identify. So that's why I have given a multiplied by b plus b multiplied by c is nothing but, if you take a common, a times b plus c. And associative law, which is a plus times b plus c, a plus b plus c, a plus b plus c. Next comes commutative law. A plus b is equals to b plus c, ab is equals to ba. Thank you for watching. If you like the video, like, share and subscribe to my YouTube channel.